In the early days, operating an automobile required not only skill as a driver, it also required strength as a driver. You see, early steering systems often provided the driver with only a limited mechanical advantage over the car's front wheels. As automobiles evolved and became larger, manufacturers were able to use larger steering wheels and more favorable steering gear ratios. This provided easier steering at low speeds, but compromised steering wheel responsiveness at highway speeds. When power-assisted steering became popular in the 60s, it helped provide larger cars with both low-speed maneuverability as well as improved road feel at highway speeds. In the 70s and 80s, many drivers grew accustomed to smaller cars that easily allowed for very responsive power steering systems. Today, as many drivers are making the switch back to full-sized automobiles, they do so by challenging manufacturers to provide them with the steering responsiveness that they've grown accustomed to while driving smaller and more nimble automobiles. Buick answers this challenge by introducing variable effort steering on 1992 Roadmaster Limited sedans and Park Avenue Ultras. By regulating the amount of fluid leaving the power steering pump, Buick's variable effort steering systems are able to regulate the amount of assist provided by the power steering system. When cars travel at low speeds, the variable effort steering systems provide maximum power assist. This helps drivers easily steer during low-speed maneuvers. At highway speeds, the systems restrict fluid flow from the power steering pump. The steering assist is reduced, and the driver enjoys a steering wheel that provides better road feel. Buick offers two types of variable effort steering on two of its 1992 models. Roadmaster Limited models come equipped with a system that's called Variable Effort Steering, or VES for short. Park Avenue Ultras come equipped with a system that's called Two-Flow Electronic Steering, or TFE for short. As can be expected, Buick's two variable effort steering systems bring with them a few diagnosis and service procedures never before required on Buick power steering systems. And the systems also bring with them a few different operating characteristics that require service advisors to probe a little deeper when trying to clarify customer complaints. This know-how release is the first to include specific information designed to help not only service technicians, but also service advisors. For the first time ever, know-how kits contain a reference manual written specifically for service advisors and a videotape designed to help both technicians as well as service advisors. To begin the program, here's a look at the Roadmaster VES system. The VES system operates with four primary electrical components. Inputs from the vehicle's speed sensor system tell the power steering control module how fast the car is moving. Based on these inputs, the control module adjusts the amount of current sent to the power steering solenoid actuator. The solenoid actuator is mounted on the power steering pump and regulates fluid flow from the pump. When current is applied to the solenoid, it engages a pintle into the pump's outlet orifice. As the car goes faster, more current is sent to the solenoid actuator to engage the pintle and further reduce power assist. As the car's speed decreases, current to the solenoid actuator decreases as well, and the pintle retracts to provide additional power assist. When the car's speed fluctuates, the control module automatically adjusts the amount of current sent to the solenoid actuator. This means that the variable effort steering system used on the Roadmaster Limited continually adjusts to provide the best combination of power assist and road feel. The final component in the system is called the steering wheel rotation sensor. Mounted near the end of the steering column, this sensor detects sudden movement of the steering wheel and signals the control module to provide increased power assist dependent on vehicle speed and the speed the steering wheel is turned. With increased power assist, the driver can more easily perform evasive driving maneuvers, even at highway speed. If the steering wheel rotation sensor requires replacement, begin by making sure that the car's wheels are pointing straight ahead, and also be sure to secure the steering wheel in the locked position. After removing the car's negative battery cable, loosen and remove the nut and bolt positioned just below the sensor. Separate the two shafts and disconnect the electrical connection on the steering wheel rotation sensor. At this point, complete the removal by disconnecting the lower bearing adapter clip and sliding the steering wheel rotation sensor out of position. Before reversing the procedures for installation, always check the condition of all fasteners. Park Avenue Ultras use a similar variable effort steering system that's called two-flow electronic steering, or TFE for short. The TFE system operates with three electrical components: the multi-function chime module, the powertrain control module, or PCM, and the TFE steering solenoid actuator. Inputs from the PCM tell the chime module how fast the car is moving. Based on these inputs, the chime module controls the TFE solenoid actuator by opening and closing the solenoid's ground circuit. As with the Roadmaster system, the Park Avenue solenoid actuator is mounted on the power steering pump. When the car decelerates below 18 miles per hour, the solenoid actuator energizes, and the car operates with full power assist. When the car accelerates beyond 20 miles per hour, the solenoid actuator's circuit opens. Fluid pressure pushes the pintle to a resting position within the orifice, restricts fluid flow, and reduces power steering assist for better steering wheel feel. It's helpful for both service advisors and technicians to understand that the TFE solenoid operates very differently from the VES solenoid discussed earlier. The TFE system operates with either full power assist or a preset level of assist reduction, unlike the VES system, which provides a constantly variable range of power assist. It's also helpful to understand that although they look similar, the TFE and VES solenoid actuators operate exactly opposite of each other. When the TFE solenoid is energized, it provides maximum fluid flow. When the VES solenoid is energized, it restricts fluid flow. When the TFE solenoid is not energized, it restricts fluid flow. When the VES solenoid is not energized, it provides maximum fluid flow. As you can see, both solenoids move the pintle outward when energized and inward when not energized. But because each unit has the orifice in a different location, the units control fluid flow exactly opposite of each other. As you can imagine, it's very important to make sure that a replacement solenoid actuator is the right unit for the application. A close comparison of VES and TFE actuators reveals subtle differences that help the technician avoid installing the wrong unit for the job. Neither the VES system used on the Roadmaster Limited or the TFE system used on the Park Avenue Ultra change the basic power steering hydraulic components used on either car. In fact, both cars use power steering pumps and gears that are similar to those used on Roadmasters and Park Avenues without variable effort steering systems. Both the TFE and VES systems take advantage of an internal flow control valve that has been part of Buick power steering pumps for years. When the solenoid pintle restricts fluid flow, the pump's internal flow control valve automatically routes excess high-pressure fluid into the pump reservoir. Designed to control pump fluid flow rate at high engine speeds, this internal flow control valve works well with variable effort steering to easily reduce the pump's output. With a basic understanding of how the two different variable effort steering systems work, here now is a closer look at how to diagnose malfunctions in the Roadmaster system and the Park Avenue Ultras system. When diagnosing problems with the VES system, it's easy to determine whether the problem stems from a hydraulic malfunction or a VES electrical system malfunction. Disconnecting the solenoid actuator disengages the VES system, and the car should operate with full power assist at all times. If a lack of power assist exists with a solenoid actuator disconnected, then check the hydraulic system for malfunctions. The Know-How Reference Manual details hydraulic diagnosis procedures for the Roadmaster Limited. Also included in the reference manual are procedures for checking the VES electrical system. The initial system check and subsequent diagnosis procedures require a few special tools. The first of these tools is the Y-power harness connector. This connector serves as an adapter to provide two power ports from the single connector at the cigarette lighter. Two tools are available to simulate inputs from the vehicle's speed sensor system. The first tool is the signal generator, while the second tool is the combination instrument panel tester signal generator. Connecting either tool to the control module requires a jumper lead that can be fabricated from hardware supplied in the terminal repair kit. Exact connector part numbers required to assemble the lead are detailed in the Know-How Reference Manual. When the test lead is connected to the control module connector, one of the signal generator tools can then tie into the control module to simulate a variety of vehicle speeds. A Tech 1 is then used to read the output from the control module. Combined with a brake cartridge, the Tech 1 connects with the other available port of the Y-power harness and the ALDL connector. Be aware that the Tech 1 refers to variable effort steering as electronic variable orifice, or EVO steering for short. The Tech 1 reads the duty cycle of the pulse width modulated signal sent from the VES control module to the solenoid actuator and displays the signal as a percentage. At 0 miles per hour, with the signal generator disconnected, the Tech 1 should read between 20 and 30%. With the signal generator positioned at the 30 Hz setting, the Tech 1 should read between 42 and 52%. At 54 miles per hour, or the 60 Hz setting on the signal generator, the Tech 1 should read between 57 and 67%. When performing the system check using the signal generator tools, it's important to remember that the signal generator replaces inputs from the vehicle's speed sensor system. If the variable effort steering system fails the system check, then the malfunction lies with the variable effort system. But if the VES system passes the system check and malfunctions when the power steering control module is connected, then look for problems with the vehicle's speed sensor system. The VES symptom table, found in the reference manual, provides help when tracking down both VES system problems and speed sensor problems. Diagnosis procedures for the Park Avenue's two-flow electronic steering system are quite different from the Roadmaster system. Because the multifunction chime module serves as the brain of the TFE system, it's important to check the module by making sure that all audible warnings and alarms operate as they should. With all doors closed, the seatbelt unbuckled, and the ignition in the run position, a slow chime alarm should sound. With the driver's door open and the key in the off position, the chime alarm should chime at a faster rate. And with the key removed and the lights on, the chime should sound at an even faster rate. If the audible warnings all perform as they should, go ahead and start the car. Service advisors should pay close attention to the next few checks because they describe a situation that might cause a customer to complain of intermittent loss of power assist when the system is actually functioning as it should. With the car idling, the steering wheel should turn back and forth with minimal effort. Next, let the car idle for 3 minutes and turn the wheel again. It should turn with slightly more effort than it did after first starting the car. You see, if the car doesn't move during a 3-minute period of time, the chime module breaks the current flow to the solenoid actuator and the system operates with reduced power assist. This action is normal and is done to prevent unnecessary wear and tear on the solenoid coil when the car idles for extended periods of time. Once the PCM detects vehicle movement, the system will immediately provide full power assist to allow easy low-speed maneuverability. Technicians and service advisors should know that the two-flow electronic steering system only shows one of two symptoms when it malfunctions. Either the car operates with reduced power assist all the time, or it operates with full power assist all the time. Even though the two symptoms are very different, their diagnosis begins with the same two tests. The first test evaluates the integrity of the solenoid actuator circuit, while the second test evaluates the integrity of the speed sensor system. All TFE electrical checks are completed using a multimeter. Begin TFE steering system diagnosis by disconnecting the multifunction chime module. With the ignition in the run position, check the solenoid actuator power circuit by connecting a voltmeter between terminal B8 of the chime module connector and ground. If the voltmeter doesn't read battery voltage, check fuse number 5 and the circuit that runs between the relay center, the solenoid actuator, and the chime module. If the wiring is okay but the voltmeter doesn't read battery voltage, replace the solenoid actuator. If terminal B8 does provide battery voltage, continue the diagnosis with the second check, which tests the speed sensor circuit. Begin the speed sensor check by raising the vehicle and placing the transmission in neutral. Rotate the front wheels by hand. With the voltmeter connected between chime module terminals A3 and B5 and the front wheels being rotated, the meter should read between less than 1 volt to no more than 4 volts. If it doesn't, and the wiring that connects the PCM with the chime module is okay, then replace the PCM. At this point, the diagnostic tests are different depending on whether the car is operating with full power assist all the time or reduced power assist all the time. If the car is operating with full power assist all of the time, leave the chime module disconnected. Start the car and again rotate the steering wheel. If the wheel turns with increased effort, replace the chime module. If the wheel still turns with full power assist, check the pump for a sticking flow control assembly. Or check for a short to ground in circuit 1387, which runs from the solenoid actuator to the chime module. If the system operates with limited power assist all of the time, and the system passed the first 2 electrical tests, then bypass the chime module and engage the solenoid actuator directly. To do this, connect a fuse jumper lead between terminal B8 of the multifunction chime module and the A terminal of the ALDL connector. With the jumper in place, the system should function with full power assist. If it does, the problem lies within the multifunction chime module, which should then be replaced. If the system still doesn't provide full power assist with the jumper lead in place, then the electrical system has checked OK and the problem is most likely in the power steering hydraulic system. Hydraulic system diagnosis procedures for a TFE-equipped Park Avenue are very similar to the procedures used to diagnose Park Avenues that don't have the TFE system. Perform the hydraulic check by following the steps outlined in the Know-How Reference Manual. The ability to maneuver a large car with an almost effortless touch on the steering wheel and the ability to provide road feel and steering wheel firmness that increases the pleasure of highway driving. the variable effort steering system used on the Roadmaster and the two-flow electronic steering system used on the Park Avenue Ultra are Buick's answer to an ever-demanding customer base. As shown in this program, the variable effort power steering systems provide steering characteristics never before found on a Buick. To effectively service these systems, technicians must know how the systems work and must also know how to diagnose and repair the systems. Also, the service advisor must know how to ask the customer questions that will help determine whether a power steering complaint is related to variable effort steering or not. For example, if a customer complains that the car is hard to steer, clarify the complaint with the following questions. Is the car hard to steer all of the time, or does it seem to be affected by speed? Is it only hard to steer after it's been idling for 3 minutes or longer? Does the car make any noises when the wheel is turned? And does the speedometer and cruise control work? If the customer complains that the wheel is loose and unresponsive, ask if the situation occurs all of the time or if it's more noticeable at any particular speed. Ask if the car pulls or wanders. The answers to these questions will help the technician quickly and correctly pinpoint the problem area. Yes, automotive steering systems have evolved through the years, and as they continue to evolve, Buick will meet the challenge of customer demands by providing answers like the 1992 variable effort steering systems.